For years, we've seen AI absolutely conquer the digital world, right? Mastering games, creating mind-blowing art, even writing code. But now, something is shifting. AI is learning to walk, to grasp, to interact with our world. It's moving out of the server and into our homes, our factories, our lives. So let's dive into this incredible leap, this jump from pixels to physical actions. I want you to just take a second and imagine something. What if a single robot with one AI brain could learn to do, well, almost anything? Not just bolting a part on a car, but also folding your laundry, packing your groceries, or clearing the dinner table. Believe it or not, this isn't science fiction anymore. It's the huge question that's driving a complete revolution in robotics. And this, right here, this really captures the massive shift we're talking about. On the left, that's the old way. Powerful but kind of dumb robots. Each one's a specialist, programmed by experts for one single repetitive task, over and over. But on the right, that's the future. A generalist robot, actually learning a complex, delicate task like folding clothes. The jump isn't just about what the robot can do, it's about its entire approach to learning.
So how in the world are we making this jump from the old way to the new? Well, that brings us to our first section. We're going to explore the next great frontier for AI. And it's all about moving from staring at pixels on a screen to actually taking action in the real world.
Look, we've all gotten used to large language models. They're amazing. They learn by basically reading the entire internet. But all that knowledge, it's abstract. Sure, an LLM can write a perfect, step-by-step description of how to fold a shirt, but it can't feel the fabric. It can't physically manipulate it. To get true physical intelligence, an AI needs a body. It needs to learn from real-world, physical experiences.
And this need for a totally new kind of learning brings us to the very heart of this revolution, the robot brain. This new type of AI has a name, and it's called a foundation model. So let's break down what that actually means.
Okay, put simply, it's a single, massive AI model that's been pre-trained on a staggering amount of data showing physical interactions. It's not built for just one robot or one task. Instead, it's like a generalized base of physical knowledge, a foundation, you could say, that can then be adapted or fine-tuned for a whole bunch of different robots and different jobs.
The analogy of ChatGPT is absolutely perfect here. Think about it. ChatGPT didn't just memorize a dictionary. No way. It learned from this vast universe of human language, books, articles, conversations, to understand context and nuance. Well, robot foundation models do the exact same thing, but their internet is a massive library of physical experiences. They learn by watching millions of robot actions, everything from picking up a cup to sorting objects, done by all sorts of different robot bodies. And this leads to a fundamental change in how we even think about building robots. The old way? For any new task, you needed a whole team of engineers to write months of really complex specific code. The new way is all about showing, not just telling. The model learns from this huge library of actions, which lets it generalize its skills to new situations it's never even seen before. It's the difference between a simple calculator and a creative problem solver.
Okay, to make this a little more concrete, let's look at a groundbreaking example from a company called Physical Intelligence. Their model is called Pi-0, that's Pi-0, and they've really focused on perfecting the training recipe, kind of the secret sauce that creates this incredible physical dexterity.
A huge key to their success is the model's training diet. And this isn't just data from one robot doing one thing. It's a rich mix, a whole buffet of data, from two armed robots, from mobile robots, and from these massive open-source datasets. Just like a balanced diet is crucial for a person's health, this diversity in data is what gives the AI its versatility and makes it so robust.
And their recipe has two main steps. First up is pre-training. This is where the model just soaks up everything from that massive, varied dataset. It learns general concepts about physics, how to grasp things, how to move. Then comes the fine-tuning. Here, they feed it really high-quality, curated data for a specific, difficult task. So the pre-training gives it breadth and the ability to recover from mistakes, while the fine-tuning gives it that deep skill.
So, what do you get when you follow that recipe? You get a model that can perform tasks with a level of fluid dexterity that was, frankly, just not possible with older models. Let's take a look at what that actually means in action.
So here it is, clearing a table, figuring out the difference between dishes that go in a bin and trash that needs to be thrown away.
And here, it's tackling the classic challenge of deformable objects, laundry, taking clothes from a dryer and putting them in a hamper.
And finally,
Carefully packing a shopping bag. I mean, that requires real spatial awareness and a gentle touch with all those different objects. And the craziest part, all of these complex, multi-stage behaviors are powered by that single base model we were just talking about.
Now, this kind of breakthrough isn't just happening in some isolated research lab. Oh no, it's becoming an entire industry movement. For our next section, let's zoom out and look at the robot revolution being powered by the NVIDIA ecosystem, because they're building the tools to put this power into everyone's hands.
At their recent big conference, NVIDIA CEO Jensen Huang made this incredibly bold statement. Look, when a leader of a company that is quite literally powering the entire AI revolution says something like this, you know a major shift is happening. This isn't some far-off prediction anymore. It's today's reality.
And NVIDIA isn't just talking a big game. They're releasing an entire ecosystem of tools. The centerpiece is GR00T, which is a foundation model specifically for humanoid robots. It even has this clever dual system brain that combines lightning-fast reflexes for things like balance with slower, more deliberate planning for complex jobs. But crucially, they're also building all the tools around it, like physics simulators and virtual worlds for training. They're building the whole factory, not just the car.
And just to show you how broad the applications are for this stuff, get this. NVIDIA is collaborating with Disney Imagineering. The goal here isn't about factory work or chores. It's about creating the next generation of expressive, engaging, robotic characters. I mean, imagine droids in a theme park that can interact with you in ways we've only ever dreamed of from the movies.
Okay, so we've seen the science, we've seen the industry tools being built, but where does all of this actually lead? For our final section, let's look at what happens next as this tech moves from the pages of science fiction into our reality.
50 million. What does this number mean? Well, according to NVIDIA, this is the estimated global labor shortage that this new age of generalist robotics could help solve.
So, while a laundry folding robot is seriously impressive, the real takeaway here is so much bigger. This tech is about creating a flexible, adaptable robotic workforce that can fill critical gaps in our supply chains, assist in taking care of the elderly, and handle dangerous jobs, ultimately transforming entire industries.
And that leaves us with one final big thought. For decades, we've struggled to program robots to fit neatly into our world. Now, we're building robots that can learn to adapt to our world, all on their own. So, as they begin to truly master our physical spaces, the real question becomes, how will we, our jobs, and our societies need to change to master them?